Mr. Warren Savage, right here.
Thank you, Sean. Well, I'm going to talk to you guys today about something that is relatively new technology. So I wanted to, first of all, do a little poll of the audience. Has anyone heard of IP fingerprinting before? Okay, that's pretty normal because it's pretty new. So let me get started here, and I'll leave some questions at the end for people who might have questions about this. Here's the big problem that we're facing in the semiconductor industry. The problem is also a benefit. It's massive IP reuse. And I like to use this chart. It's from Semico Research that shows the percentage of reuse in SoCs today is getting close to 80%. So if you look at today, there's maybe 150 or so IPs per chip that may be sourced from maybe 50 to 60 different suppliers. And so it's a huge amount of data that has to be tracked and kept track of by your semiconductor company. And each one of those IPs has an IP contract behind it that very specifically describes what its use limitations are and what are the constraints associated with that. And there's a problem within these semiconductor companies of keeping track of all the data that is sitting there. So that's the downside of this massive reuse. So the two big questions that are facing every semiconductor company today is what's in my chip, what IP is contained in there, and then the other thing is what IP is in my company. And if you ask most companies, they'll tell you, I think I know what's in my chip. I have no idea what IP is in my company because I'm in a design group and there's other design groups and I really don't know what other people are using. It's a big issue for companies just to communicate what they have within the company. And there's typically an IP manager within the companies or maybe multiple IP managers, and they're armed with these very sophisticated tools like Google and Design Reuse, ChipEstimate, of course, here. And they use email for support, use Excel, Outlook for record keeping, and they access the IP through FTP, which has been around for about 40 years or so. So pretty old tools that are used to keep track of all this very important data. Where we see things are going is we actually have a piece of software called Xena, and it's a software for enterprise level management of IP that ties together the supply chain handled by the purchasing folks up in green. So you have your purchasing, your legal, people doing vendor selection that feeds in the requirements from the SoC team, and that's for the external IP. And then your internal teams are developing your own IP, and there's a place for keeping track of that as well. So you have an ecosystem here of internal and third-party IP that's being integrated and managed at the enterprise level with a piece of database software, basically cloud-based software. So that's our Xena product, but that's not what we're here to talk about today. We're talking about something that's even beyond this because this requires what I call proactive IP management. And proactive IP management means that somebody's making an explicit effort to document the IP they're buying, where they're buying it from, storing that information in a reasonable way, and it's humans entering that data. So anytime you have humans touching data, it is prone to errors. It's the garbage in, garbage out problem. Fingerprinting solves that. I call it sometimes the IP backstop because it doesn't require on humans, it's machines that are determining what IP is in my chip. And so that's what we're going to talk about today. So I wanted to kind of first start highlighting those proactive things you can do that have other benefits beyond compliance and finding out what's in your chip. But the key thing we're going to talk about today is this new technology called fingerprinting. Just a little bit about our Xena system. It has all these, it's a database system, keeps track of the products you have, the contracts, all the chips, support portal, and then this compliance section, which is new, and this is the fingerprinting stuff I was talking about. This idea came about 2 or 3 years ago when we were talking to customers about Xena and how you could proactively manage their IP. And the customers were saying, that's fine, but we haven't had any systems for managing our IP for a long time, and is there anything you have that can help us determine what we've done in the past? And so we actually started thinking about this in a big way, and we came across a novel idea we invented called fingerprinting. And that's what I'm going to talk about now. Um, so what is fingerprinting? So basically a fingerprint is a digital representation of an IP that is taken from a chip. So we have a scanning piece of software called Fingerprint. It's like a utility or an app, and you basically point that utility at an IP database. And you don't have to modify the IP. It doesn't put anything into the IP, but it generates a file called a fingerprint. And within that fingerprint, it will scan the IP. You don't have to modify your design flow. You can do this after the fact. So you could do this on designs that are years old. It doesn't rely on tags. Most people here are familiar with IP tagging, the GDS level. If you have tags, it makes fingerprinting more powerful. But if you don't, it doesn't need them. And one of the cool things is that you can detect an IP in a chip without having access to the chip itself. And I'll explain how that works a little bit later here. But that's the really cool part, is you can do this outside of the design. So, and if you're interested in this fingerprinting app, you can go to this link here. It's corestore.com, and that as an example there, you can download the fingerprinting stuff, and you get a white paper there, and there's a whole bunch more stuff that you can learn there by self-service, basically. So again, what is a fingerprint? So a fingerprint's a digital representation of a chip. You scan a group of files to create a fingerprint. And fingerprints are very, very tiny. So for each file in the IP, it's 75 bytes. So you can take a huge design and you can create a very compact fingerprint from that. The other thing about fingerprints is we don't want to have it very mysterious what a fingerprint is. So we decided to make the fingerprints in a text format. So you can use a text editor and you can open up a fingerprint and you can take a look. Hey, what did this tool do? What's this data look like? And if you look at it, you'll just see a bunch of basically hashes is how it works. It supports all kinds of IP and all kinds of files. So it's not even restricted to Verilog or VHDL or GDS. It supports all those formats like your Verilog VHDL, System Verilog, System C, also GDS. But actually much more interesting, it can also support embedded software, which is also IP that's being licensed more and more as well. And it's very secure. You cannot reverse engineer a piece of IP from a fingerprint. So that's a very key feature there. Now, let me explain a little bit about how this works in practice. And I use this diagram all the time to explain how fingerprinting works at the overall semiconductor ecosystem. So there's two boxes here. There's blue box on the left and red box on the right. So let's talk about the left box, and that's the IP ecosystem. So that's all the people that are talking at ChipEstimate.com here today, people who you see here at DAC. They all have products, and so each of those suppliers takes a fingerprinting tool, and they produce a fingerprint file, one fingerprint file per IP, and they can register that IP in a public repository called the CoreStore. So this is sort of like your FBIA central fingerprint database, where as an IP supplier for free, you can register your IP, and that IP is then available so they can be detected later. And it may be detected without your knowledge. You might have sold your IP to company A, and an engineer from company A may have put that IP on a USB stick and went to company B. And with fingerprinting, that allows that IP to be detected at company B. And company B might be quite surprised to have discovered that they have a piece of IP that they didn't buy in their chip. So that's the left side. That's the ecosystem side. What's really interesting, and this is where we make money, is on the semiconductor side. So on the semiconductor side, we talked about these IP librarians, the IP managers. As the IP comes into the door, the IP can be either fingerprinted before it comes into the company, or the IP librarian can themselves choose to fingerprint that IP before it comes into the door, before the IP goes on to the file systems of that company. And in that case, the IP librarian is doing the fingerprinting and storing the files, storing the fingerprints in their own little local repository here, which is basically nothing more than a directory. The IP is then used in an SoC, and at the end of the design, like let's say toward the tape-out stage, they will use the fingerprinting tool, same free tool, and generate what we call an SoC fingerprint. And the SoC fingerprint is then used together with the fingerprints that are in the CoreStore and in local fingerprints, and that's fed into this thing called the DNA analyzer. And the DNA analyzer produces a DNA report of your SoC that tells you what IP it discovered in your chip. So conceptually very simple. It's actually very fast to run these things. And it produces a report that looks, well, let me back up a little bit. I'm going to show you what a report looks like. But I think a really important thing to understand is the difference between a tag and a fingerprint, because that seems to confuse a lot of people. They're actually quite different concepts. So if you have an IP tag, this is a piece of code that's inserted in the IP, either the soft IP. There's an Accelerate standard for IP tagging for hard and soft IP. The soft IP really doesn't work because the tag doesn't survive the synthesis into the net list. But GDS, you put a tag and you insert that GDS into layer 63 of the GDS. And that kind of goes along with the IP to track the IP in a way. But it's not perfect. The foundries can take it out. It can get adjusted, deleted. Fingerprints are different. Fingerprints basically take the real IP and extract from them a fingerprint. And the fingerprint is stored outside the IP itself. So those can be dealt with separately from the IP itself. And I'll show there's some benefits to that, doing that as well. But that's a big difference. Tags go in, fingerprints are outside. Here's a little bit of what a fingerprint looks like. So like I say, we decided to make fingerprints in a text format so you can actually see what it looks like. So at the kind of information that's contained in the fingerprint is the name of the chip, the revision of the chip, the company that owns the chip. There's a fingerprint ID for that particular chip or IP, and how many files are comprised in that fingerprint. And then we go down here, and then we'll see for each of these 67 files here, there's a big number here. This is basically a file name, and then we do a SHA-256 hash to create two numbers here. One is of the actual IP. Every line of the IP is parsed and scanned. The second is we do the same thing, but we strip out the white space. So we can tell if somebody's inserted a comment, it's the same IP and things like that. And that's extensible, and over time we're going to be extending that to, the number of the IOs is the same, or the same number of registers, or things like that. So this technique is extensible, and it can be expanded over time. But to start with, we kind of decided to start with like the 90% rule to get most of the value in the first part. Okay, so what's in the DNA analysis? So I said it scans a chip looking for fingerprints. Fingerprints can contain your internal IP as well as your third-party IP. It pulls them remotely from the core store and generates a DNA report. And the DNA report will tell you what IP was found in the chip, what versions it detected, or maybe multiple versions it detected, what tags were detected, and it gives you a score indicating the confidence level of that, and I'll get into that next. And it shows you what files are missing or modified in some way. So we're actually seeing a lot of interest in that feature from the military or aerospace industry that's worried about malware and people modifying the IP and putting a backdoor into a satellite or things like that. So this can help detect if there's a modification. This can kind of tune you into where that modification took place in the IP. So especially if you use contractors, that's kind of a nice feature. So finally, this is what a DNA report looks like. This is the DNA report we put together with some of our own IP at Silvaco. And here's a bunch of IPs that are detected here. This multicam, some cold fire processors. We found one GDS2 file that was tagged here. And it tells you the most likely version that was detected, the provider, and this is kind of boring, it's one company. The scores. The score tells you the probability that IP is contained there completely. The method, this can be extended over time. And then sometimes there's multiple versions that were detected. So this is something you have to kind of debug to see what's going on there. So to kick down to the next level of this, I don't know how to go back with this thing, but if you clicked on one of those hyperlinks, it pops up a new tab here. And so we clicked on the multi-can there, and it says this version 2.0 was detected at 100%, meaning that 113 files were detected, and we found all 113 files in that chip. So it has a perfect score. You can see an older version of a fingerprint was also scanned, and you can see that between 1.2 and 2.0, there's quite a few file changes, about the same number of files, but quite a few files were touched between that version and that version. So if you had two detections here where you had like version 1.2 and version 1.2, 1.3, there might have been a small difference there, and you would want to look into that. And the way you do this is you kind of scroll down this screen of all the files, those 113 files, and it'll tell you, like, this file is missing. This file here was detected. This pack file here is present in 2.0, not present in 2.0. So you can say for constant that was a 2.0 file. So that's very useful feature. So the applications of this is quite broad, and actually we're coming up with new use models for this all the time. One of them is creating an electronic bomb, so you can track internal and external IP. And this is completely quantitative. This isn't in somebody's spreadsheet that might have missed something. This is actually coming out of the design databases themselves. So the files are there. The other thing is IP quality, and one of those things is this came from a customer in Japan that wanted to use this in design reviews. So at the end of design reviews, to have a complete list of IP, do I have the right versions of all the IP, and they go through a checklist. And they can do the checklist on the technical side, they can do the checklist on the legal side to check for all those things. And auditing is another thing that's pretty interesting for this. So with auditing, we have the capability of being able to give fingerprints to auditors. So if your company's being audited for fingerprints, maybe you don't want to let them in to look at your file systems. The auditor can ask for your fingerprints, and they can go off independently without having the IP itself and do the analysis. Then they come back and ask you, can I see the contract for that IP? Can I see the contract or the PO for that IP to show that you really paid for it? So they can do all that independently of getting their hands into your code. So pretty useful feature. So that's the end of my presentation. Any questions?
Any questions for Warren? That's okay. Yes.
The same with the software?
Yes. Yep.
So you can find Silvaco's IP on ChipEstimate.com and explore away. We have videos, white papers. Warren occasionally does a blog, or and we'll pull that in to our newsletter. So great stuff. Go to ChipEstimate.com for all of Silvaco's IP. I want you to stick around because we want to give you a ticket because we'll have a drawing around 2:30. Okay? Thank you so much. Have a good day.